Hi everyone, so we are meeting after 2 weeks, and so how was your experience with the assignments? Before moving forward to the next topic, our next topic is indexes and replication and sorting. And so before we move on to those three big topics, I want to know like how was your experience with the assignments? Shreya just SMS that she will not be joining. Yeah, yeah, Bhagavat, your solutions were quite close. I mean, I don't remember which ones you have not finished yet. So, yeah, just go through those documents and then you can see. Okay, okay. So I'm happy to see that most of us could got hold of. I mean, almost all should understand what does it mean by MapReduce. And when it comes to handling big data, probably out of all the concepts, MapReduce is the one which require intervention from people, and and MapReduce is the one which scares almost all the people, because when we talk about big data, we talk about Hadoop, and when we talk about Hadoop, out of all the components of Hadoop, people are worried about MapReduce really much. Similarly, in MongoDB also, aggregations and MapReduce are the two things which almost everybody skips. Theoretical parts everybody is okay, but when it comes to the real matter, which is aggregations and MapReduce, people tend to skip it. And but I'm actually happy to see that most of us have been able to figure it out and have been able to understand it. And those who are not, they will be. I'm sure they have not got the time yet. But those who have not actually submitted the assignments. So okay, okay. So Samta says that JavaScript knowledge would have made it slightly easier. And yeah, so the thing is that you do not learn things unless it is part of some objective. And if you had to just learn JavaScript for the sake of learning it, then it would not make much sense. Now, if you go back and you tend to learn JavaScript, you will have a good reason to do so. Okay. And every time you are solving a big problem involving a MapReduce, you will definitely go through online and search various kinds of libraries of JavaScript. And also it will take you now a day or maybe at most a day to just go through JavaScript, because now you have your objective clear. I mean, that is how I generally do. I start with a problem statement, then I dig down into the components, and then I dig down into the language which is used. So since I have my objective clear, it becomes really, really easy to learn a language. If you go from the other way around, the way we have done it in college, meaning you first pick up a language and then you try to learn it. So in those cases, what happens is that your learning is very sequential and not very robust. So my belief is that you pick up a problem and then you learn the language or you learn the underhood tools. Yeah, yeah. So Gaurav, that is the right approach in today's times. You can use Java, but under the hood you will be, it'll be the same thing. The only problem with Java is you have to do a setup environment and all of that. And while dealing with MongoDB, it does take a lot of efforts to write MapReduce in Java. So, so that is the reason that I avoid using Java when it comes to MongoDB MapReduce. Okay, okay. What does Robo Mongo do? Oh, this looks nice actually. I will give it a shot. This looks nice. This looks quite useful. Oh, that's nice. That's nice. So it's sort of looks like it's sort of a decent IDE where you can browse and similar to SQL clients. This looks interesting and useful. Others can also use others can also use this. Thank you, Gaurav. It looks neat. Let me also try it out. And then and it's free also. Okay. So before I move forward, do you guys have any specific questions regarding assignments? Oh, you are disconnecting quite often. So any particular question you have with respect to assignments, or we should move on? Okay, Gaurav was facing issue with respect to Mongo restore. Right, right, right. Actually, I too faced the same problem, and what was happening is when I was doing it locally on my version which was older Mongo, I was able to restore the that file. But when I tried to restore it on my Linux machine, which was a newer Mongo, it gave me a problem. So instead of that, so your problem, Gaurav, looks like that of, while Mongo restore, probably you will have to give a complete folder sort of thing. D company, and then there will be one more folder label. And while Mongo restore, I actually gave a database name. as well, and a collection name also. Okay, maybe you can do that. I think with the 2.6.3 there was the problem in restoring. So I tried 2.6.2, but instead what I did was I exported it and then did a Mongo import instead of Mongo restore. Hmm. Because Bhagavati, your Mongo is little older. That is the reason it probably worked. I'll also share the exported JSON. Okay. Okay. Any other question you have before we move forward? Anyway, those questions you can anyway independently ask me. I think today's classes are a little bigger, and maybe they will. I'm very sure because these involve a lot of concepts. So they are. It's very sure that it will overflow to the tomorrow's class. Okay. And yeah. So because today in today's session we are going to discuss indexes, replication, and sorting. Okay. Okay. Yeah, thank you, Samta. Thank you, Samta. I'll make a note of it. That's interesting thing because I too find different approaches interesting. And probably what I'll do is I'll share each other's assignment with each other once they are complete and in a shape. Okay. And so you can see and go through the other assignments as well because that gives a good insight. Is that okay if I share each other's assignment with the other people, other solutions to the problems with other people? Bhagwat, Gaurav? Okay. Once you finish your okay, okay. Great. So what I'll do is once I get a decent number of answers and somebody is okay with sharing it, I'll share with other people and that should be fine. Okay, okay. It's actually a nice idea. So anybody who is just finished, I'll share his assignment across. The only thing is that I did not want to share it uh, till everybody finishes their assignments. Otherwise, we don't get newer answers. We will just get older answers. Okay, like for example, yeah. Okay, okay. Yeah, Gaurav, you finished those things because your approach when I went through, your approaches were right. It is just that they need to be finished. Okay. Your approach, the approaches you have written are pretty good. All you have to do is finish it. Okay. Okay, let me, so I start with indexes again. As described earlier, indexes is exactly what it looks like at the end of your book, where you have a phrase or a word and then followed by the page numbers where it was found. Okay. The only thing it doesn't have the exact location on the page where that particular phrase was found. Uh, So, and there are a couple of more nitty-gritties here and there. But on the prima facie, this is what an index looks like. And in case of MongoDB, there are multiple indexes for multiple such indexes. This is just one index on keyword. There are similar indexes on other things also, such as if you plan to do a index on title. So there will be a separate index in which titles are sorted by are in sorted manner and then followed by the page number and page location. So similarly, in MongoDB, to make your queries faster, you create these indexes, and I'll show you how much difference does it make for when you create indexes on various columns. And this is not a very new thing. If you are from SQL background, so all of you would be knowing how big a role index plays. So in the last session we talked about aggregations, and in aggregations we did lot of querying, but we never thought whether those queries are intensive on database. Okay, are we doing scans or are we just searching? So as the data grows big and our queries grow higher and higher every day, you would require indexing on the fields which you are looking for. Also, indexes, the common property of indexes is that the keywords are sorted in the index. Okay. In case of databases, so they first started with take out all the unique values, create a sorted list in which they do a binary search. And binary search is jumping to the middle of every set and ignoring the section of the uh, so dividing the whole set into two parts, and then seeing where the stuff which I'm looking for would lie. Okay. And so using a binary search, it is very quick to locate the data. Now, so everything started with the simple binary search. They moved to binary tree. The moment the indexes became so high, that so big, that they are not able to store them in a memory in one shot. So they started using something called B tree for storing the indexes. B tree is nothing but uh, partial. I mean, only the partial data is stored in the memory, so that it helps in jumping very quickly, while almost all data is stored in the disk. Okay. So basically, B-tree is a specific topic. All you can remember is B-tree is something, a binary tree, or binary search tree, which is mostly stored on the disk, because disk reads are costly. So binary tree is a model where there are minimum number of reads are required from the disk to actually search. So you can, for time being, you can just if you want to do a further research, you can go online and try to understand what a binary tree, B tree is. B tree is the structure which is used in almost all databases for indexes. Okay. So you can actually, if you want to do a study, you can go forward. But B tree is good enough keyword for when people ask you in interview, what data structure do we use in indexes or in case of discussions. So it is important to know that there is something called B tree, in which partial most of the data is in the disk, but B tree assists you quickly locating that data using a data structure. Okay. Second, an index is on collection level. It's not on means it's like similar to saying that an index in an SQL database is on table level. Okay. We say that this column of this table should be indexed. Similarly, this field or these field of this collection should be indexed. And then this is how it looks like when you have not indexed and you are running aggregations. Okay. So when you are running aggregation, map reduce, and almost everything such as match, sort, and sometimes projections also, the MongoDB ensures MongoDB uses indexes, and the if the index is not available, the MongoDB goes through each document from bottom up in a collection to and matches your conditions if there is no index. Okay. So, a very quick question. Say, when you compare two strings, it takes 1 milliseconds. So, if you have to compare the same string one by one against 1 billion records, it takes 12 days. Okay, it takes 12 days to do so. Now, if you index or you do a binary search against these 1 billion record after sorting, how much time do you think it is going to take? No, Bhagwat, I'm not going to cover the B tree, but maybe I'll make a simple video describing B tree and share with you, or we'll find some video describing B tree which will be simpler. So this is the question. So comparing 1 billion records one by one against a record was taking 12 days. Now you sorted these 1 billion record and you are trying to just quickly locate a word in this 1 billion record, meaning you created index over these 1 billion records, and after index, how much time do you think it is going to take? Any wild guesses will do. Any wild guesses will do. And a billion has 9 zeros. Gaurav says 1 millisecond, but a single comparison was taking 1 milliseconds, right? So it cannot be 1 milliseconds. It has to do more comparison. Samta, any idea? Or or in simple words, if there are 1 billion records, how many comparisons do we need to do in order to do a binary search? No, it's not n log n because n log n is for sorting. N log n means that if there are n records, the total time will be proportional to n into logarithm of n. Okay, okay. Yes, yes, you are right, Gaurav. So basically, when you are doing a binary search, so you perform a jump of half and half every times. So if you keep on if you keep on dividing something by 2, say x number of times, so how much this x should be such that you are able to break 1 billion into into 2. So there are 1 billion records. You're slicing them half every time. How many times will you have to slice it? Say there is a huge uh, say 1 billion meter strip is there, and you have to cut it from half every time. Okay, and only one part has to be considered out of the two. So you have a strip, you cut it from the middle, you discard one, keep one, and then you do repeat the process, and you keep on repeating the process. And can you imagine that it will hardly take uh, it will hardly take around 30 30 cuts to bring 1 billion meters to 2 meters or 1 meter. Okay, it will take around 30 cuts only to bring down a billion to 2 meters, or less than that actually. Okay, So this is an interesting part. So actually, if you do, it will take around 30 milliseconds. So Bhagwat, you are right. So this is the magic of indexes. So after creating index, it will approximately take 30 milliseconds. And every time, every DBA takes the credit of when the DBA takes the credit of improving the search, improving the SQL queries. It's mostly the index which is to be done right. Okay. Similarly, in case of MongoDB, when you're querying using aggregations, MapReduce, or any other mechanism, it should be done on. I mean, most of the time you will find that index was missing. That's why it took so much time. So I hope I could get you the importance of indexes. If you have a was my analogy clear when I said that you have a 1 billion meter long strip and you're cutting it in half? Was that clear? Great, great. Because that's an important aspect to understand when we talk about indexes. Now let's talk about what happens under the hood in indexes in MongoDB. So we take, say, users and we are doing find, okay, or we are doing match, for example, using aggregations. So you say users dot find and then you specify score as a parameter and less than 30. And you imagine that what you have done with your scores field in your collection is that uh, basically what indexing has done is it has created this nice horizontal line which goes from 0 to some maximum, or which goes from negative minimum to a maximum, and this a whole list is ordered. Okay, so to cater to such query, what MongoDB has to do is has to locate where is 30 on this number line. Okay, so it located here. Now we got this list. Now MongoDB will go from one by one from minimum till 30 and find the actual documents. Is exactly like saying go to the back of the book and find out what all words are starting, what all words uh, are lesser than boy, okay, from the index, and print those, and it will do this. Okay, so it's not only equals, it's not only a comparison operator is straight away equals operator, but range also is range criteria is also done using your basically using the binary search or using B tree search. Okay, so range also uses the indexes. Okay, had it been say greater than 18 and less than 30, so it will first locate the point where 18 is there, and then it will locate where is the point 30 is there, and after that it will just traverse from 18 to 30 and then find out all the documents and print those. So it has to only scan one document at a time, only in the result set, which it has to do it anyway. Okay, so when we say here, if you see, score colon 1 is the index, meaning we have created a index on the field called score, and 1 means on ascending order. Okay, we'll come back to this, but this is how it looks like when you say db.users.find score colon something something something. So under the hood, this is what it is going to do. So this is a very nice graphics which should be clear. Okay, I've got a question from Gaurav. But indexing is also takes time, which is one-time activity. But at every inserts or update, we need to update. Yes, yes. So you are very right. So indexing takes time. Indexing actually means sorting. If you have a lot of data, then indexing is sorting, meaning every time you create an index on an unorganized thing, it is going to take approximately n into log n. Okay, if you have got, say, log n is base to 2. So if you have got n records and you are sorting them, it takes time proportional to n into logarithm of n. So that's the thumb rule. So it takes quite some time. Okay, because sorting is the main process. Similarly, when you're inserting a record and when you are actually updating your indexes, it takes time. It takes time proportional to again equal to the amount of time you take in searching and little more. The time you take to locate a word in index, first when you're inserting a new record, what you have to do is you have to find, I mean, under the hood, what MongoDB has to do is that find where is this word in index and then update it at that location. That's what MongoDB does. So every I insert and update is equal to, a search query on indexes, and it is going to take a little bit of time. Yes, you are right, Gaurav. So you need to be little judgment. I mean, you need to be little cautious. Also, it takes a lot of space also. Okay, not too much of space, but takes at least space in proportional to the column size, the data in the column at least. Yeah. So these that is one thing which you need to be worried about. So this is what indexes is, sort of a recap which I had already discussed. So I hope this diagram is clear, because if you have this picture in mind that this is what it is going to do under the hood. So we said score less than 30, which means it will locate where is 30 in this number line by jumping. By first it will jump to the middle, say it will jump here to near 45, and then it says I'm looking for number, and it hit 43 for example. And the moment it hit 43, it says that, oh, I'm looking for less than 30. I mean, I'm looking for 30. So just ignore everything after 43 and focus, concentrate on this. And then it will jump to something like 22. And we say, okay, since I am looking for 30, which means it cannot occur on the left hand side of 22, which means it will ignore the left hand side. Now it is left with a number line containing starting from 23 to 43. So it will again jump and finally it will locate quickly where is 30. Okay. And when we say print, I mean, the moment it hit a point where left hand side is lesser than 30 and right hand side is greater than 30, it has found that location. Okay. And then it will start printing those documents one by one by finding the references back. Great. So I think this is good enough. In case you still have doubts, so how does exactly the indexes work, feel free to drop me a message, because probably 90% of the people know that indexing just works, but they should know that why does it work and how does it work. Only then you will be able to optimize any of your system. Does Mongo index by default? mm, no, Bhagwat. So the because every time you're inserting something into a regular data, it has to make the relocations, move the data down, and all that sort of magic it has to do. Although databases have come up and the computer science has come up with very decent data structures, still, if you try to index as we go, Okay, meaning every time, so when you have 10 records, you created an index and you are keeping on updating this every time you do. It will be less efficient if you compute the total time. It will be efficient if you do it in a single shot. Meaning, let let's import the data, import all 1 billion records, and then you create indexes. The time there will be really small as compared to the time taken in the individual transaction. Okay. So that I can you can discuss it, and I can prove you mathematically also that why does it take so much time. Yes, actually, if you have 1 billion record and the key that was there, if you are creating an index, it will actually take more than 12 days. Okay. Okay. In the theoretical example, it will actually take close to 12 into 30, these many days. So that was a theoretical example. Okay. Just to create a wow. But it does happen a lot. It does happen. And that is why when we say 12 days or 12 into 30 days, which means that our we are doing it with a single machine, and single machine is not capable of doing it. Okay. That's why MongoDB will use the sorting and create the indexes using a network of computers. Okay. So now let's move on to what are the types of indexes. So types of indexes, first is default ID. This is something very important. Every document has got an ID which makes the document unique, and by default when you create a document, insert a document, MongoDB keeps an internal index on underscore ID. You cannot stop MongoDB from doing so. Okay. And basically every this is the default index which MongoDB keeps. And then there is something called a single field, then compound, then multi-key, geospatial, hashed, text. So I'll take one by one and keep on moving. So let's talk about single field. This is the most simplest one out of the lot. So we are saying db.collection name dot ensure index on this field. And when we say ensure index, index has to be either increasing order or decreasing order. Okay. So why does it matter to create increasing or decreasing? So when we are looking up for something, say we are looking up for user ID tomorrow, and we want to print, we don't want to sort by default, we just want to print, we just want to print the data in ascending order of user ID. Okay. So if we have created the index already in an ascending order on user ID, then we do not need to sort it again, because all it will do is find those documents in this index and traverse the index, and whatever is the order, whatever is the is the order in the index, it will print those. If it is minus 1, which is descending, so your output will be in descending order. If it is increasing, then it will be in increasing order. It wouldn't. So in case you generally need your, when you are looking for somebody based on their name, or based on their name, if you're looking for somebody based on say score. Okay. So if you always need the output to be sorted in ascending order by score, then you should create a, I mean, ascending order index. If you always need a descending one, then you create a descending one. So that's the reason why ensure index provides you uh, column one order similar to the find. Okay, so this is clear to you. And once you are done with creating indexes, you can do dbRecords.find and explain, and it will tell you that it is a B-tree kind of index. If the index is not there, if the if there is no index at all, it will show you a in basically kind of a I mean scan, forward scan or something, document scan probably. It will tell you clearly that there is no index on this column or in this table. Okay. And also indexes are stored in a table called system.local.indexes, in which you can see what are the indexes created on what table in your database. Now so hope this is clear. So to create an index on user ID in an increasing order, you say ensure index and then you specify this. Now the second kind is that we create a multiple indexes like this. Okay. And this is the way we create. So we'll say db.records, and then say user ID colon 1 score ID minus 1, meaning we are creating a compound index on table called records, in which the user ID is increasing and score is decreasing. And under the hood, you can look at this number line. You can imagine that on the number line, we have created these combinations of user ID and score. So user ID is AA1 and the score is 45. And then second user ID is CA2 and score is 75. Then user ID is CA2 again and the score is different while the user ID is same, and so on. So you can think of the index under the hood as the total combination of user ID and score IDs, and in a while the user ID is increasing from left to right, the score is decreasing from right to left. So this is how we create an index, and this will simplify and make our search on these two criterias extremely fast. Okay. So say we are looking for CA2, and we are looking for people whose user ID is greater than CA2. Okay. Greater than or equal to CA2 and score is less than 90. Okay. So first it will quickly go through the first index and then reach to some point here, and then at the same time then it will look for, and when it has figured out one section in the index which qualifies for your first filter, then it will look for the second filter and will give you the results out of the intersection. So this is called compound index, where you create index based on multiple columns. And why is this important? Because when you are looking for because when you look for things to, I mean, when you always apply criteria together, okay, say you are always looking for user ID and score ID together, that means it always makes sense to make a separate index containing these two fields. Does the search order matter? Order of the field. I did not get, Bhagwat, your question. Does the search order matter? Order of the field. Okay, maybe you need to rephrase it a bit. So this is what is called compound index, where we uh, index a collection based on two columns, and then comes something called multi-key. Okay, so multi-key is interesting. Say you have a field which has got sub-documents. As you can see, can you see in this in this example? So look at this. I have increased its size. So you look at this collection here. Okay. Here, what you can see is under address, we have an array of objects, and those objects, all of them have a zip code. Okay. So when we look for zip codes here, also, I forgot to mention this part earlier. When we are creating any of those indexes, you can create indexes on sub-documents as well, not only at the top level. You can also say create an index on user ID dot first name or user ID dot second name. So those kind of indexes you can create if you have documents of multiple level. In multi-key case, basically it's an index on array. So if you have created an index on zip code, here if you say create an index on addr.zip in an increasing order, colon 1. So when you are looking for a particular document in this, you'll get it very quickly. Okay. So in case your document is in this form, you do not have to worry about restructuring it. The only interesting part comes in when the zip is outside the array also. Okay. When the zip is outside the array, then you can see that. Let's take a case of these two. Okay. Here you have zip code inside the array. This is an object which is inside the array of addr. Okay. So you create index called addr dot zip. Okay. Which means it will make it faster to search on zip. It is also, so when you say db.collection.find addr.zip equals 10, you'll get this very quickly, or you will actually get this whole thing as part of it. Okay. Now look at this. You have, other than this, you have another document, another document which is which has basically under addr, it directly have a zip. Similarly, there is another documents in the same collection. So when you say zip greater than 10, you will actually get this document, this whole document. Okay. And this document, this document, and this document. Okay. So all three documents you will get. Okay. So when you're looking for when you are finding things on addr.zip, all these three will be searched equally. So all these three lookups are same. So indexes, when we say multi-key indexes, which is basically array kind of indexes, the syntax is same for both subdocuments as well as subarray. Hope I did not confuse you guys. So we search on score first and then on user ID. No, actually, the compound interest, the technique is a bit different. It basically creates, I mean, basically combines the two values and creates an index on top of it. Okay, so it's equivalent to single lookups. So Bhagwat's question was that Now, Gaurav's question is that, okay, let me just complete Bhagwat's question. What happens if the order of these fields, since the binary search will be different in both cases? Not really. If you think about that, you have combined the two values of these two columns together and uh, and created a sort of a binary tree of composite values, then you can search based on the values you are looking for. Okay, but this becomes a little too big an index. Okay, okay. So this is the compound interest. Let me explain again. So basically, all the distinct values, it has done a multiplication, basically a cross between the two values, and created a whole number line on those values. And now whenever you're looking for, say, imagine that it has put a dash between the two values. After doing all combinations, it has done a dash between a dash b and then created this list. Now when you're looking for things equals or something like that, it is going to quickly locate that value in this number line. Okay, in this number line. Okay. I I don't know whether it is equivalent to searching two indexes, but as far as I knew that compound interest mostly behave like a single field, not a dual search. Just that while creating indexes, both the values are combined, and basically intersection is done on the two values, and then a whole single value is created out of the two values. Basically, you create all permutations of these things, and then you create a single number line, single index, and then you can search in it. Okay. Exact mechanics, maybe I'll need to do a further research, or maybe I need to look at their code, what exactly they are doing. Right, right. The order matters. When you're looking for things, order matters. In case you put, if you have created composite records on A and then B, then you should be looking at things in that order, not B comma A. Then the index, I think index is not respected in that case. Could you explain when one should use compound key index on two fields and when two separate index on two fields? So, okay, this is a very good, interesting question from Gaurav. So, one is that we create indexes on each column. First is we create indexes on each of the fields of a document separately. Second is we combine the two fields together to create indexes. Excuse me. And then, so the thing is, whenever you are very, very sure that these are the two things I'm going to look for always together, okay, or my queries always use these two columns together, okay, then it makes a lot of sense to create a compound index on those two columns. Okay. If you are you are not sure, do not create an index because index is heavily memory intensive. Okay. Okay. Any questions till now? Because today's discussions are going to be little difficult. I mean, a little tricky. So I would like more questions now than later. Great. So I'm moving on. Yeah, that's the point, Bhagvat. Okay. Now, so we talked about multi-key, which is basically you can create a index on the array values like this, okay, and which is equivalent to this. Do not worry about that. MongoDB takes care of most of it by itself. Now, the real important thing, is geospatial index. Okay. So, when you are looking for something in a geographical space, it is actually difficult to do it right. I tried couple of times myself, and it was extremely difficult. Say, we were creating a simple service. I was creating a simple service. I mean, basically, one of my guys from uh, uh, rotatewave.com. Okay. So what he was doing is he was creating a Twitter-like service. What the Twitter-like service does is that you keep on tweeting with your location, and it will show you all the tweets around your location. Okay. So people are tweeting with their location. Basically, it's a location-based Twitter. So when he was creating that, and when he was trying to come up with a system where, given the whole globe, you you give a coordinate that give me tweets in a 1 kilometer radius from this particular point, this particular shop, or this particular coordinate. I want to see all the tweets, or I want to see all the tweets around me in a 1 kilometer radius. To do that computation, he was finding it very, very difficult, extremely difficult actually. So we sat down together. I said, okay, let's do this search. Let's do this technique. So we tried three, four techniques. First one was we divide the whole plane into sections of rectangles. Okay. And then we do the search. Second was we divide the whole globe into the zip codes. Okay. And then basically we divided the whole globe into zip code. And whenever we are saying uh, get me all the people around this in 1 kilometer radius, all we do is we find that in which rectangle does this point lie. So we find that rectangle quickly. We have created an index on XYZ. Basically, we created a zip code the way zip code was invented long, long ago. We gave a number to each rectangle, and whenever people and we created a way to convert a coordinate into the zip code and back. So we were trying to do all of that, and we created a separate service, we created a separate server, we tried to do all of this magic together. And then we said, ki, why don't we just simply use what is already there? So we first tried basically a Solar server. Then we said, why don't we use MongoDB itself? It has got a great special indexes. I mean, this is like long, long back ago. Okay. So then we ended up running MongoDB just for these location search, and it really worked well. It really worked well. So basically, when we talk about geospatial, meaning g- given a coordinate system, it gives you a very various kinds of very, very important way to search for things. Okay. So the earlier indexes, we always talked about a number line in which there is a singular line and we are searching from left to right. We are just going binary search from this to that, and it's done. But when it comes to coordinate system, we have to look for two values together. Okay. It cannot, I mean, usual binary search will not matter to us. Okay. So that is when the geospatial search matters a lot. In case of, I will give you more details. So there are two two kinds of geospatial indexing which MongoDB provides to you. First one is 2D and second is the sort of 2D sphere, meaning 2D is sort of a flat surface. Okay. And 2D sphere, this is not 2 sphere, it's 2D sphere. So when we create, when there are two kinds of indexes, one is 2D sphere and other is 2D index. 2D index is for the values where you want to do searching based on if these values are lying on a very flat surface. While 2D sphere is index is for those cases where you have got Earth-like situation where the 2D is not really flat, it is basically a round object. Okay. So when you are trying to create sort of rectangles on this Earth's system, if you think about latitude, longitude, and so they are not really straight lines, they are curved lines. Okay. So in those cases, if you are searching for things on the sphere like surface, and in those cases you use the 2D sphere. Otherwise you keep on using the otherwise you use 2D index. But frankly, 2D index was an older way of doing things in case of MongoDB when the newer algorithms did not were not implemented, and it uses an legacy coordinate system. Okay. Okay. So when you are saying ki create an 2D index on this column, your column value need to be in this format. A column called LOC. It should have either an array in which the first value is longitude and second value is latitude, or it should be an object in which in this format in which first key should be len. They should have two keys, lng and lat, and it should be in this format strictly. So people stopped using 2D index the moment 2D sphere came by, and probably 2D sphere is probably the best way of doing things, and it's quite efficient also. So this is geospatial index, meaning I want to look for something in a geography, not only on the number line, not greater than this value, less than this value, or that value. I want to look for something, say, give me all the people who are tweeting around me in a radius of 3 kilometers. Or in this boundary, in this rectangle, you draw a rectangle on the surface of Earth and then say, get me all the people living in this area. Okay. So that kind of search. So you have created, you remember our assignment where we talked about population. Okay. Where we were talking about zip codes and everything. And there was let long coordinates also. So we could use that data to give you a demonstration of 2D sphere, but we'll do that later. So this is what are typical two kinds of indexes are there. And 2D index uses a older way of coordinates this way. If you can see these two ways, okay, lock in this format, while the 2D sphere uses something called GeoJSON format, which is quite universal in behavior while representing coordinates. If you are going to search for something in your data need to have the coordinates, right? So that data need to be represented in some format. So this is one format which is universally accepted when you're defining your data. When you are saying that this is my point or this is my value, this is how you define. You say location, my location colon is this. Okay. The kind is point and the coordinates is this and this. Now you are drawing a line. Okay. My my path colon this object, meaning it's a line which goes from this point to this point. Similarly, we can draw a polygon. We can say my my flat, my building colon this object. So this is how you define any geographical location in terms of GeoJSON, so that it can be indexed using 2D sphere. Okay. Now, when we are doing indexes using using geospatial, these are the various operators involved. First is GeoWithin, which says geometry within a boundary, and then you have GeoIntersect, where two boundaries are intersecting, both the coordinates, even with GeoWithin as well as GeoIntersect. When you define that, define the coordinates, you define in terms of GeoJSON, which is this kind of format. So when I say GeoWithin, so GeoWithin is like GeoWithin colon polygon this, meaning I'm looking for something in this area, or we can say GeoWithin these collection of things. So there is a geometric collection in which you can combine all of these shapes together and say this is my geometry. Okay. So these are all standard GeoJSON format. And here you have got near. So you can, for near, you can say near this point. And near sphere as in near that sphere. Internally, 2D indexes roughly work like this. These are called interval trees. Okay. So basically I'll just describe you in a very simple words. So what you do is, what does this MongoDB does as part of this algorithm? It divides first the whole plane into four sections. These four sections. Say this is your huge rectangle in which you are looking for people in a certain radius, and you're trying to search in all of that. So you divided the whole plane into the four parts, and you gave them a name called 0 0 1 0, and then 0 1 and 1 1. Now further it is divided. Each one of them will be divided exactly like this fourth square has been divided, like this. And it will keep on going on further and further. So you gave a number to every location. This number will look like this. Okay. And when you are looking for something, when you are looking for any value, the closer these values are, they will physically be closer to each other. Okay. So any number starting with 0 0 is more likely to be closer to the another number, another location starting with 0 0, and so on. So this is how you divide the whole plane, and this is how the 2D index, simply 2D index work. Okay. It has got a lot of troubles also, such as if the values are here in this on the boundary, then it is very closer to 10 10 as compared to the other one. Okay. So when you're looking for something, you generally first convert that location into this number, and then you are able to reach to this. Okay. Basically, it's kind of a scheme of giving zip codes to the locations again. Okay. And then you can look for. And in 2D index, we give, say, db.collection.ensure index, and on this particular field, this field, I want to create a 2D index. And then we can also define one more additional field to index. That's it. And then you can say other configurations here. Okay. So this is how we define 2D index. You do not use unless it is absolutely required, and when it is absolutely required, this 2D index is when you have a lot of legacy data in the older format, not in GeoJSON format. Okay. The second format of the indexes is GeoHaystack indexes. These are optimized for searching in a very small area around a point. Okay. So if you have a need in which you only look for uh, points around a data around a single point, you generally go for GeoHaystack. Oh, you came earlier, dude. So Bhagavat is asking for a coffee break. Just give two more minutes. I will go through GeoHaystack and then. Does anybody else need a coffee break? Because it's 1 and 15 minutes. So these are the GeoHaystack indexes. So uh, Gaurav, Samta, have you slept off or you need coffee break or it's okay? I think they have slept off. Okay. Gaurav, are you there or you? I think I'm a little boring today. Let me try to, you know, great, great. So, Bhagwat, say something. Hello. Do not worry. Joe special is not missed. So you have not slept for too long. Okay. So it's not missed. Don't worry. And so let me just take 5 more minutes to explain, and then we can take a coffee break. Okay. Okay. The other format of we only discussed about 2D index, which is rarely used, so you have not missed much. And then we discussed about how the 2D index work internally, so nothing to worry. In case of GeoHaystack, basically it does is it divides the whole sphere into chunks and group them together, basically into buckets, and then it groups them together. This is also rarely used. I prefer it not to use it because the after a point of time, the moment I increase my radius, it starts giving me troubles. Okay. So it's only good for when you have your bucket size, your radius fixed. You are always looking only for 1 kilometer, not beyond that, or something of that sort, or very smaller radius. So in those cases it's okay, but otherwise it's not great for other kind of thing. When the bucket is smaller, this is optimized for a smaller area. You are only looking for say few kilometers, and you define that in the beginning itself. And when we talk about flat geometry, this is good. For real cases like Earth, when you talk about the globe, you should prefer 2D sphere than this. And basically it creates buckets, and each bucket contains all the documents nearby that particular location. Bucket size you define by how much kilometers are you looking for. And the moment you cannot change bucket size too much. If you try to search for beyond a certain limit, it becomes very, very difficult. Okay. And it internally uses the geosearch command. So let's take a look at how we define the position in this format. It's sort of a legacy format where this is how we have mentioned. You see the POS, this part. We said my latitude is long, my longitude is this, My longitude is this, latitude is this, and this is the 100th restaurant. Now, if you're looking for restaurant in that particular area, this could be interest. This could be used. Okay. And when you are saying indexes, you say ensure index on this column called POS, and type is this. Basically, the kind of index we are trying to create, and then we can say another one. We can also add one more field to the index called restaurant, and we say that is on increasing order. So we you can combine one one field together with the as a composite index with the with any of these geospatial indexes. And we are saying create a bucket size of 1 unit. Whatever unit is there for your lat long, in the same unit you can define your bucket size. Meaning, in case you're going beyond one 1 kilometer, it is going to be difficult for this guy while searching. Okay, so Gaurav has got a question. So bucket size will perform well. That's Gaurav's question is when does this haystack performs well? It performs well as long as it's in bucket size, and you can see that we have defined bucket size while creating index. So whatever your bucket size is. So if you create too big a bucket size, then it has to again iterate over in that bucket. And if you have created too small bucket, then also it's a problem. So generally what you do is you create bucket of your decently I mean the decent locations, in the sense that say your objective is generally to provide people a search only on the in 5 kilometer radius or 2 kilometer radius. You generally create a bucket size of 1 or 2. Okay, in those cases bucket size performs very well. Okay. So bucket size is configurable. It's up to you how big you want it. If you create too big, then also it becomes slower. If you create too small bucket, it becomes again slower. Okay. No, actually we are going extremely slow. Anyway, I like to take time. Do not worry about that. Okay. Even if we are not able to finish it today, we'll do it. But I like to explain things properly. So Gaurav's question is, Samta's question is, what values can be given to bucket size other than one? So bucket size in the same unit in which you are creating your coordinate system. If your coordinate system is in meters, then you use meters. So you can use 10, 15, 1, 2, whatever. Okay. So we should provide bucket size distance up to what distance it performs well. Okay. So basically, whenever bucket size is basically proximity, meaning the radius of the circle in which you are looking for. Okay. I mean, I think it's you can say the diameter of the circle when you have divided the whole thing into say squares. So whatever is the is the width of the square is what is called a bucket size. Okay, I think looks like you're creating a smaller search size. Yes. So when we say bucket size 1, it's actually pretty small. Okay. So it's based on your general requirements. Okay. Because Okay, so moving on with the 2D sphere. 2D sphere kind of indexes when you're looking for something with operators like geo within, or aggregation function was there called geo within, and geo near, uh, near. So in all of those, an index is used, and a geospatial index is used. A geospatial index could be 2D index or 2D sphere index or geo haystack index. And out of all the three, I always prefer 2D sphere because it's faster than almost all, and it is more general in nature. Okay. It is faster in general, but those two are of very specific case. Okay. It helps you do a real calculation on the sphere when you talk about geography. And most of the geometry we talk about is generally limited to very smaller areas, but when it goes global, because 4 square uses MongoDB for doing exactly this thing. Okay. So, so on 2D sphere, the calculation is on sphere like geometry, like Earth, and then it uses GeoJSON as the format of the location. And second is that any of 2D sphere indexes cannot be used as a shard key. Shard key I will describe later. In on very simple words, when you're dividing data amongst computers, amongst the replica sets, multiple when you're slicing the data, then you cannot use this particular indexed as the shard. Okay. It supports various kinds of commands such as geo within or operators like geo intersects, near and near sphere. Okay. Now, say in places, we give an example earlier. We defined we defined a place with this way. Okay. This is how you define the coordinate system. You define a type, and then you define basically you create an object in which there are two values. First is type and other is coordinate. This is how you write. This is where this particular park is, and the name of this park is something, and other data you can write whatever you wish to do. Okay. And this is how you search, this is how you create index on it, and then you can later on search for it in the territory. Okay, this is how you do it. So you say, all you say is, here you will write ensure index on this field. Okay, ensure index on this field. That's it. Okay, and this is basically exactly this way. So these two rectangles are exactly the same. Okay, okay. So as you can see that, so basically the difference between, if you can you see? So the difference between near and near sphere is that near is sort of uh, the proximity to a point, and second one is point, both the points are located on the sphere. Okay, both the points are located on the sphere. So near is for the flat surface when you're looking for the flat surface, and near sphere is on the sphere kind of case. When you are looking for the points near a point which is on this sphere. So this is like in general what a 2D sphere looks like, 2D sphere index looks like, and then we have hashed. Okay. So in case of a, mm, 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 So you can create an index called hash in which you want to randomize values. And the main objective in hashed as in what it will do underneath is instead of simply creating putting the things into order or putting say names of people it under the index it will all do is under the hood it will sort those indexes and create the index. Now hashed is an awkward thing. What it does is it takes the name and convert creates a hash of it. Okay. Hash hash you can think of something a random number generated from this one. Okay, which is difficult to predict. Which is difficult to predict. And this is done specifically for the purpose of sharding. As in, when you are trying to distribute your data uniformly across the servers, then you create hashed field, o- hashed index on a field, and then you do a sharding on that basis, which means as we discussed a long back, the problem with when you're dividing the data amongst multiple servers, the problem becomes that it is not uniform. So to create a uniform division of data, what you do is you just randomize the values, or you generate a hashed values, okay, and which will be very uniformly distributed. Okay. So that way you can create that's the sole use of a hashed index. So why I am is skipping it a little faster. Okay. Okay. Hey, let's take a break, and after the break, we will actually have to do a lot of things. There's a lot of things to do. Right now, we have okay. There are too many things. Anyway, never mind. We will actually can do it combined tomorrow also, and maybe replication or sarding we can take tomorrow, and we don't have to rush actually. Okay, we don't have to rush because these are the concepts which will be used almost in other databases also, and almost the concepts are same across other distributed computing databases. So even if you are not using MongoDB in your daily life, then also it is important. Okay. So yes. So what I'm going to do is after this theoretical thing is required. After this thing, I'm going to give a demonstration, create an example, and give the demonstration to all. Okay. So let's take a break for 10 minutes and then come back. Okay, Bhagwat. Hi guys, I'm back too. Great. Okay, great. So next thing that comes into picture is the text indexes. In earlier days, databases did not provide you search inside the text. Okay. For example, Microsoft SQL came up with the text search only in their last edition. So searching based on text is, really a great thing to have. Like in my product, I had to invent my own way of doing things. I had to use a product called Lucene to provide text search. Just a second. It is giving a warning to me saying that your network speed is bad. Are you guys able to hear me? Hey, I'm sorry. I'm really sorry. This got disconnected. Can you hear me clearly? I think you can't hear me. Hello? Yeah. Hi, Samta. Can you hear me? Anybody? Hello? Uh, Great. So now you can hear me, right? Screen coming. It's I've just shared. Samta Gaurav, give me a confirmation that you are able to hear. For some reasons, my connectivity is good, but it's getting disconnected. Great. So, when I was building my product called T-Bits, I had to I invent a way so that I could use the traditional databases. Traditional databases. You had to go with a solution like Solar, SOLR, or you had to use something like Lucene, or you had to invent your own way of doing text search. Because text search involves a lot of things. First, text search should give you immediate results on querying for strings in a combination of and, or, you can say not, as well as it should automatically figure out that the commonly used words such as a and the should be removed from the query, as well as they should not be indexed. Now, and other than that, it has to search for things like reading. The reading should match, the keyword called reading should match with read when people are searching for it. And also, based on the frequency of words, it should give you a great amount of ratings. As in, these keywords are found in this document this much. Okay, based on number of keywords found, how well they matched, all this sort of thing. And other, there are many aspects of text searching. The other aspects of text searching are that language neutral. Imagine searching for things in Hindi or Chinese. None of the database actually provide that. They only provide uh, basically English search. I mean, Microsoft SQL hardly provided any other search. I'm not sure about Oracle, but none of them had this kind of functionality. So people generally ended up building their own solutions uh, for location-wise search or for text-wise search. Okay, but thankfully, in newer databases, people are trying to build these kind of things, these kind of features inside the database itself. Then there is one another part of language called stemming. Stemming is what? As I described, reading should match with read. Okay, gardening should match with garden. When people are looking for gardening should also match with a decent shape. Similarly, s or es, plural or singular, should also match. So this mechanism of suffixing s, es, ing, and basic, you know, tion kind of thing, generate and generation, they should also match with a decent amount. So this suffixing with various phrases, various letters is called stemming. Okay, so stemming is extremely useful. I remember when I was building my product called T-Bits, and we were providing very flexible text search. So we were trying to use Lucine's stemming algorithm. That time that was really a big deal. Before that, I was trying to build my own, and my mind was buggy because every time we see a new use case of a language. Okay, and stemming is very language specific. For Hindi it's different, for English it's different. So generally, so far I have seen with MongoDB, the stemming is only related to English language, not with any other language. Okay, so this is what it is. So the way you create, basically, you take out all the content out of the document like this, and then say you have a collection called reviews. It has got a field called comments. So you want to take out all the text from comments or other fields. No, Gaurav, it doesn't use Lucene APIs underneath. I'm not sure if using libraries or something, but I doubt so because MongoDB is mostly written in C while Lucene is in Java. So I'm not sure. I might have to do a research, but so far I have not uh, seen that. And then you say take out all the text from comments and index it using a indexing mechanism called text. And while you're searching for something, you say db.reviews, find text, a text is your command, and then search. And you can also use uh, a text in the while you are matching using aggregations. So this is how you index and search in case of text. So should I move on, or is there any doubt about text or hashed index? Hello Sakti, you're a little late. Okay, okay. Now there are, does Mongo index this as in what? Does Mongo index this text in a field? Okay, so Gaurav is not clear about hashed index. So I will just go through a quick way. And if you have other questions, please ask now. Anybody else is having question? Okay, okay, okay. Let me just go back a step. So basically, hashed indexes are specifically designed for sharding purposes. Okay. These are not useful for any of us, any of the practical use cases. Basically, all it does is, are you aware of a mechanism called hash? Hash is basically converting a string into a number, or converting an object into a number. Okay, where uh, I mean it is basically converts a large or converting a large content into a smaller number so that it could be quickly looked up. That is called hashing. Okay, that is called hashing. So basically, the hash which gets generated is generally very random and randomly distributed. Okay, so effectively, if you are hashing all the people's name in this world and then you are distributing them, it's very high chances that they will be uniformly allocated on the in the alphabets. Okay, and hashing, there could be multiple techniques of hashing. One is MD5, other is SHA-1, other is you invent your own, like divide every number by 26 and then add it by second. divide every first letter with 26 and then add the next one, and so on. So there could be hundreds of ways of hashing. Okay. So hashing is basically converting a string into another form such that it is fairly randomized. Okay. Because if you are trying to distribute a login IDs of the people, there are say you are maintaining a user database, and the primary key of this user database is user ID. Now user ID of the people would be very biased, in the sense that nobody will have a user ID starting with Q. Only few people will have, or hardly few people. And but for A and for E and for S and for T, there will be too many of IDs, and hence there will not be any uniform distribution if you are trying to slice them by ID. And that is when people came up with saying that, why don't you just create a number, or smash this ID and form a hash. Okay. So people came up with various scheme of hashing. Okay. One was simply creating a number by summing up their ASCII values and then dividing by 26, or some sort of that scheme for each string, which converted it into an integer which is uniformly distributed. Okay. So people came up with various kinds of scheme, and that is hashed. And I'm not sure what kind of a scheme MongoDB uses. Or in case you are not sure about what indexing, let's say MongoDB was not providing you this kind of scheme and you have to divide your data across sharding, what you could do is use MD5 checksum to convert your value into another form which will be fairly random, and then that can be used as a shard key. So hope I'm able to explain it. Okay, okay, great. So Shakti is saying hash index is applicable for every column on the document. Yes. Since hash is a fairly random thing, there is no point of doing a range queries on hashed indexes. And these are specifically done for this. Second is indexes, text indexes, which Bhagwat is asking. So basically this is how you create the index. This is how you create the index, by saying this, and then you start searching for it. It's as simple as that. If you try to look for something like A, it will say that A is not found. Okay. It takes all the word. So Bhagwat is asking what happens when we create the index. Good. So it takes all the words from this string, splits them, and also slices the stemming out of all the things, and then puts them into a dictionary sort of dictionary sort of data structure internally. And when you look for a word, it quickly looks up into the dictionary and gives you the whole document. Was I clear, Bhagwat? Right, right. You remember we were having discussion about splitting the records, right? So while we split the records, there is a lot of engineering required there. You have to remove, you have to split it based on space, tab, new line, and other characters. Similarly, if there is a dot at the end of the sentence, you have to remove that one. And if there is a capitalization, lower capitalization, all those things you have to take into account. Then apostrophes you have to take into account. Bhagwat's this, or say Gaurav's this. So there is apostrophe s, so that you have to remove. In case people are looking for Gaurav, you have to remove that ses from Gaurav, and then you should be able to search. So there is a lot of engineering that goes into text searching. Okay, and this is like 30 years of knowledge of people into text searching. And I know this because it took me a lot of time to build a search engine, even though I was using a Lucene kind of thing. Okay. Can we use the split text index for other queries? What is split text? Now, yeah, that whole thing is automatically done by Lucene for you. Okay. And you can actually, yeah, you can create as many indexes as you want. Okay. On as many columns as you wish. So it will all it will do is it will take out all those text from all other fields and then start indexing that, and then you can search. Now moving on. Right, you can do that. Yes. Good point, Bhagwat. Yeah. So Bhagwat is saying that can we use the split text index for other queries? The comment is split into this and say I want to find the occurrence. Yeah, you can do that basically. Now there are common properties you define for indexes. One of such properties is TTL. One of such properties is TTL, and TTL is I don't want this document to be in my collection after 5 minutes. Okay. I do not want this document after 5 minutes. And this is when it comes to into play. So this is an important aspect because when you are storing a transient data which has to be for only some time, and you do not want your database to be accumulating such data, in those cases you want to expire the documents. Okay, you want to expire the documents. So in those cases what you do is you create an index, ensure index, and my field on which the creation date is there, I tell that this is the field which you have to keep a check on for timestamp, the creation time, and then expire after 5 sec whatever seconds are there. Always make sure that this task of expiring document runs every minute. Okay, this task of expiring documents will run every 1 minute and will delete the data whatever has expired that time. Okay, this is an important aspect because to implement this kind of thing, you always needed a lot of engineering because it's not very straight away to do these things. Okay, you always because you have to keep a schedule of things. Yeah. So a real life example is that say you are only processing data for a window. Okay, that window is say 24 hours. So every hour you will have to expire the documents which are older than 12 hours. So any document which is older than 12 hours, you want to just throw it away, and so that it's not included in next batch. So for say cases like um, the performance of our ad campaign in last 1 day, we just want to see, it's hard requirement to just see the last 1 day data. That's it. Nothing more than that. So in those cases, what you do is you expire the document. It does not mean that you should not keep a backup copy of it. You should always keep a separate backup copy of it in case the data is important. But say there is a collection, there are two collections. One is which has all the logs. And the second one is only an hourly data out of that whole section. So in this hourly data, you keep a you always stamp a document saying it was created at that time and it should expire after 1 hour. Okay. Such that you just need an insight on hourly data. In those cases, these TTL logs come very, very handy. TTL indexes come very, very handy. So I hope that was good enough real life example. Second, it doesn't support any compound indexes. And in case you are created at is a field from your documents. If it is in your document, if it is an array, then the value which is the lowest out of the array will be considered while so say created at is multiple values 1 2 and 3, just taking a case example. So whatever is the minimum, it will be considered that, and it will be deleted earliest, not okay. So that is why you should take care in while mentioning your field here, it should be generally a date and make sure it's a date. Okay, avoid it being an array or anything. Oh, sorry. I think I should have mentioned this. It means time to live. Okay. So TTL, sort of, I always forget to mention it. TTL means time to live, and these are basically sort of when things expire after some time, we call them TTL. Now, second one is unique. Okay. This is another common requirement from people that, hey, this field I want it to be unique. Okay. Other than ID, I want similar way, the way ID is unique in every document, we also want this particular field to be unique. And for that, you need to have basically you need to mention a property called unique colon true. Similar to underscore ID, that column will be considered unique. Now, and this is applicable for compound indexes also, meaning if you want to say the combination of these three values of my document always need to be unique. Okay, and this is a very common requirement, saying a combination of phone number, say a combination of a phone number and first name should always be unique. Ensure that. If somebody is violating that, which means there is something wrong with it. Okay. If there are two documents having the first name and the phone number same, that means that that's not allowed. Okay. And in database is quite common. So you just mark those fields a colon 1, b colon 2, and then say unique equals true. Okay. And now it will start putting that. Now take a case. Now take a case of, and this uniqueness is only valid across documents, not in the same document. How can it be a same document? Say you have, take this case. Here you see there is a document which has a property called A. A is an array of values. And what are those values? Each value is a document. Okay. Now in this case, A dot B has got two values, 5 and 5. Both are same. Now if you're creating unique index on A dot B, it will allow this kind of document because uniqueness is across documents, not in the same document. But if there is another document with the A dot B equals 5, then it will say, oh, this is not allowed. Okay. If there is another document containing object A dot whose value is A dot B, whose has A dot B's value as 5, that will not be allowed. Okay. So these are the few important aspect, and the another very important aspect of this unique constraint is that if the value, if there is a value x whose value is null, and so when the moment you're trying to insert a document with a null value of a field, then only one such document will be allowed. Null is considered a valid value, and another document with null will not be allowed here. And it will throw an error saying, "Hey, this is a duplicate document. You cannot insert another value with null." And that is when you use something called a sparse index, which I'll talk later. So we talked about TTL property, in which a document is expired. Sparse, we enforce that these documents are unique. These values are unique. And then we have sparse. And what is sparse? We say that it is okay. It is okay to not include these documents into the index. So, so let me put it this way. So while we were creating unique index, we said that we want this value to be unique. Now what happened was, we created a unique index on a column which is null mostly. Okay, and then it started giving error. In such case, what you do is you create a unique as well as sparse index. Meaning, a sparse index means in case your document does not have this value on which sparse index is created, this document is not going to be added into the index at all. So it skips the document which does not have that field value. Okay, so you created a index on say name of people, or say a middle name of the people, and you are saying that middle name should not be should be unique all across people. So if the middle name is missing, it will not be added at all into the index. Okay. So so basically, if you want a unique ID column of a document to be empty, then you create unique as well as sparse index on that column. Hope I could clear what I'm talking about. Okay. Can I specify which type of document to expire after TTL? No. No. That is why I'm saying that compound is not supported, and it's a very good question. Thank you for this. And yeah, it doesn't. Basically, there is no way to actually say right. This is a very good point actually. So that, because that's a very fair requirement. That's a very fair requirement that I want to expire these kind of things after this much time. So what you do is, while that's a good point. So while creating ensure index create at this, expire after this. Okay, 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 okay. So what you can do is you can mark, say you want to do what you're trying to do right now, and you created a separate column called created date in this document. Okay. Now put values for created date only the case of you want to really expire the document. Okay. And while creating a TTL kind of index, you say that it is an sparse index. Okay. Meaning, if the created date is null, then this document is not going to be considered in the index. Okay. So you should be able to achieve this kind of property. Whatever document you want to index, you just put the created at value. I mean, whatever document you want to expire out of this whole collection, you say my creation date is this, meaning only expire this document. And while creating an index, what you do is you create an index based on this field and make it a sparse, meaning sparse means Only if there is a value for this field, it is going to be considered in the index. So hope that answers your question, Gaurav, but it's a pretty good question. Oh, okay, great, great. Can one collection have multiple indexes, and if so, how to use one index versus another? Yeah. So basically, aggregations follow all the indexes together. Okay, aggregations basically indexes are used for aggregation. Can one collection have multiple indexes? Yes, it can have multiple indexes. If so, how to use one index versus another? It's pretty simple. So we when we talk about TTL, unique and sparse, they are used along with the other indexes, while all other indexes are based on columns. And based on column values, what you're looking for, you create indexes. Okay. Separate. I indexed on one field and then on another. Yeah, you can index that. Then so basically, it's up to your requirement. What exactly you are looking for while searching? What are the things you are looking for? So you scan all your queries and figure out that these are the indexes I require on your on my collection, and those are the indexes you create. Right, right. So there's a whole philosophy around how does MongoDB figures out, and it's little tricky. How does MongoDB figures out which indexes to use? And sometimes it does skip your index. Okay. So in case of ID, say there is an ID field and you say sparse is okay. Or in case, let me just give you an answer. So basically, it has a way to figure it out, and there's an interesting aspect to think about it. It does a lot of optimizations. Okay, such that when if you have say three indexes, you have two columns but three indexes. One on A, other on B, and third one on A and B, all both together. Now when you're looking for A comma B together, it is going to use the third one. While if you are going to putting a constraint such as A equals this and B equals this, then it is going to use the other two indexes. And it does figure out in the same manner. If you think about each index one by one, it is possible to figure out that what is the optimal way of using it, using various indexes. And also note that when you are ensuring index, you can only create one kind of index on one value. Okay, it should not be that once you said ensure index on created date as 1 and next time you said colon 2D index instead of 1. In this case, your older index will be overwritten and the newer 2D index will be taken care of. So if you created index on A, index on B, and index on, uh, if you ask for B and A, then the individual indexes are going to be used, not the composite index. Okay. This is what I have seen so far. But ideally, the second AB index should also be used. Okay. Now let's move on. So these are hands-on. I will give a basically uh, hands-on demonstration of various things. This hands-on script is also shared with you. So let's start with something called TTL indexes. So we have a document like this. Okay. Now you can see db dot log underscore events dot find. We have got this. Great. And now we want to create an index which will delete the document after 5 seconds. And we are saying, so in this document, this is my created date. Created date is what? My current date. When I say new date, it is a current date, okay? And I created a document with that. Oh, sorry. I always forget that. I think I will share the whole desktop. Okay. I will share the whole desktop. Okay, I'll share my how can I share my whole desktop? Yes, yeah. Okay, good. And yeah, yeah. Okay. Now, now for some time, while I am giving demonstration, maybe I'm not able to see your questions, but have a little, I will have a look at it after maybe 3 4 commands. So what I did was, let me just increase the font size also a bit. So I went to my Mongo command and let's see what exactly am I trying. This is my document. This is my document which says I want to insert into a collection called log events a document with created date such and such, log event as another attribute with 2, and then log message is this. So I created this, and now thankfully this should be deleted. Okay, now there is only one document. It is inserted very well here. And created date, if you see, is this. Now, if I say that expire after 5 seconds, it should delete after 5 seconds. But as I told you that it takes around 1 minute or around 1 minute to run the job. So at most it would take around 1 to 2 minutes to delete this document. And now it's deleted. Okay. So basically, whenever we have to keep only transient data, we use TTL. Now look at this. We want to enforce. We want to enforce the enforce. Says we have a table called accounts. Okay. Right now, let's just see. Is there a table called account? No. So we don't have a table called accounts. Now we insert data into. Let's first we can create TTL any index before or after creating the collection. So we created an index, okay, which says that create an index on text ID field and make it unique. And we are let me see if there is some urgent question. You guys can see right now. So what I'm trying to do is that now I'm inserting a value for text ID equals 1, text ID equals 1, and then second one is that 2 inserted. And the moment I'll try to insert this, the third one, gives error caused by blah 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 duplicate key error index. This is a duplicate key. This is exactly the error you used to get when you insert a duplicate underscore ID in the document. So this is the role of a unique ID. Now let's have a look at interesting aspect, which is sparse. So let's say we have something called scores, and we want to create sparse equals to true on that thing. Okay, scores dot ensure index scores colon 1 and sparse equals true. What does it mean? It means that anywhere we encounter scores as null, it will be skipped. Now let's go to this. We are inserting user ID colon 1. It has null. Now in case we are uh, okay, now let's say another one. Now this person has got 82. So the second one is going to be included, while this is not going to be included in this the the index. The index is based on score. First one is not included at all, while second and third one are going to be included. Now look at this. Now interesting aspect is that when I say simple score.find, it gives me the result. Okay, it gave me, I'll just say project underscore id colon 0. Now it gives me all these three records. You can see first one is without the score and second and third. So in the index where I'm looking for score, the first one should never be resulted. It should never come as the result. Now another important aspect is that if we are trying to sort, sorting also requires indexing. As I told earlier that if there is an index on a field which is needed in the sorting or in the find, then the index is used. So but the the sparse index is skipped when we talk about sorting. Okay, let's just see. Why it is. Do you see anything wrong with this syntax? DB scores find and then sort. Oh, actually the minus sign was different. I could not see that. So if you see, when I say sort by score, it still gave us three results, which means it is not actually using our sparse index. It is just because, so the way to actually see is if I say hint. Hint is a way of telling MongoDB that your judgment of using index is wrong. Use our judgment, and that's where it uses our index. And since our index is sparse, it has skipped our document. The first document, which did not have the score, has been skipped because we told specifically use our index. Okay, and uh, and this one does not give you a this one does not give you a correct results. It is not actually using your index. Okay. So basically, objective of this exercise was to demonstrate the the meaning of a sparse index. So if you are forcing a sparse index, a document with the missing value will not be listed. Okay. So what was the question? It's the same effect. It's the same effect. Okay. Unable to execute query, error processing query. So when I say hint, right, it means use this index. Okay. Unable to execute query, error processing query. It's a bad hint. I think in case of hint, right, you have to provide one here. I'm not sure if you can provide zero or other things. It is just a syntactical thing. Okay. Because we need to keep some value in a thing. That is why it's you need to provide that. Okay. So could I answer? Was I able to answer Bhagwat your question? Bhagwat's question was, what if I provide hint as a score colon minus one? So it's a syntactical thing. You have to, instead of just providing nothing, you have to provide one. Okay. Now let's go back. So and also when I say less than or something like that, sparse index is not used. Sparse index is not used in that case. Okay. Okay. Because sparse index will anyway skip those values. So just understand that part. Maybe we can use it in the hint. Actually, if you use it in a hint, right? Maybe, wait a second, Mike. You guys have a different question. If the sparse index was specified as score minus 1, okay, okay, let me, yeah, that's a good question. So if you, so sometimes saying if we create a index like this, ensure index, and then say minus 1 here, okay, then can we use it as a hint here as a minus 1? Yeah, then you can use it as a hint. Okay, okay, you're right. You're right. Okay. Probably you cannot basically I think you have to provide exact same syntax as you used by creating the index. Meaning uh, index by this field and in this order. Okay. So hint is exactly the same syntax as your index creation. Okay. So your index definition includes both the name and the index. Good, good, good. Excellent. Okay. Thanks. Okay. Now we have got here. Okay. Now let's okay, so other use of sparse index as I talked, which is little important when you have to create tables which have a uniqueness constraint. So imagine that you want to keep a uniqueness constraint on score. Okay, and you have this db.score, db.scores.insert, and these are your data. Okay, okay. Let me just first drop the table called score. I hope this stuff is shared. Okay. Now objective is to create. So if we are creating a uniqueness index on the score, these two documents are going to bother you a lot. Okay. These two documents are going to bother you because they cannot be inserted. If you see this, if you say simply if you say score equals 1 and sparse equal unique equals true, it is going to bother you a lot. Let me have a look. So this is the way it is, and you say unique equals true. Okay, now you have created a unique index without sparse. The moment you try to the moment you try to insert these two documents, it is going to give you an error. That is why what you do is that uh, we say first drop index, drop index. You have dropped the index. Now create another index with sparse equals to true. Now you can add these four documents happily. Okay. Now if you see db.score.getIndexes, it shows you that you can see that scores.getIndexes, and it has a unique index which is also sparse on the column called score. Okay, this is the one. This is the one. Okay. Now, so was I able to demonstrate to you the use of sparse? Sparse when combined with unique allows you to have the null value for a field. Okay, let me have a look at the good, good. Now let's have a look at the other one. We were talking about this part, right? Here, let's just create. So now let's talk about text indexes. Okay, this is my text index. I have created a document called reviews, which has a field called comments. Okay, basically there are two documents. Actually it was already there. Anyway, never mind. So we have called two documents having a field called comments, and we want to create a text index so that we can quickly search on it. So say db.reviews.find, and then we want to say, now our usual mechanisms do not let us search in this, and say I will focus on a little bit of on find. Okay, so it says nothing is found. Okay, nothing is found because we have not created an index yet. Ensure index, and then I say and then I say comments, and I say text. So I'm saying that create a index on this column. Okay, just a second. Did I ensure index comments, and then I say this. No, I think this should create very well. Let's just look at the keyword text. Am I missing something? Mm-hmm. So I have got reviews which has this. This is a nice thing, and ensure index comments, and I say text. Okay. No, unique index. So Shakti has got a question. You can create any indexes whether before or after. It's not a problem. It's just that you get an error later on. Okay. Which anyway you will get in the beginning also. So you can create all the unique indexes after also, as I demonstrated during the session also, where I inserted the document, then I was trying to create unique index and it was giving errors. Okay. So why it's not working properly? Is it taking too much of my... Okay, it already exists, which is fine. I don't mind. And say I do this. I think this should work. Why hasn't this worked? This is fine. This is fine. So let us say, and yeah, you're right. Let me. Bhagwat is saying that why don't I check? Why don't I check the explain? Yes, that's a good point. Thank you. It says properly. It says there is a text cursor available, and if I okay, does it need an array now? Is there a change in the way things used to happen? Oh, this one is giving results, and while this one, no. This is awkward. So the first document is properly indexed while second is not. Strange. Reviews.find. Huh, okay, this is a nice thing. Let's say I'm searching for thing. It is giving results while the second one is not. Comments. Okay, and let me see. Use. Actually, for some reasons, this index is not created. If I just take the first one, now I say get index is okay. Now it doesn't have an index. We'll create an index on this db.reviews and then say ensure index on the column called comments and then say text. That's it. Now it is created. Now if I say find and then say text and then say search for my string and say index, which is one of the string. Okay, something wrong with this. mm, will it work? Mhm. So for some weird reason this is not working, while if I insert another document into this reviews.insert and then say comments and then say hi, how are you? Will it work? No. Will this work? No. Is it taking time? Okay, and let's look. Okay, so probably what is happening here is it's considering these things as stop words and skipping those words which are quite common. So high is working. Okay, high is working, but the other keywords are not working because it's thinking them as a stop words probably. Stop words are those which it skips. Okay, it's indexing properly, everything is fine. And I don't understand why this part. And there is something wrong with the documents created in this. Anyway, I'm not able to locate that what exactly is wrong with this particular statement because any document I'm adding with this statement, it's not indexing it at all. And anyway, but for other things, it actually works fine. When I added this kind of comment, I was able to search properly. Okay, and say I said hi, and then or India, and then it returns properly. Okay. Okay. Maybe some problems with the codes and all. I'll figure it out later. And in case of find, while you are doing using these indexes, you could specify various kinds of things. You want a column. Okay. You want a column of text score together with it. Let's say since our high worked. So here it shows you the score. Okay. The first one is 0.75 and second one is fun. And for whatever reason it has given the rating to the first one as the more important, second one as more important than the first one. Okay. And if I say India, then the only the second one will match, and the rating should be 1. Or rating is still 0.75. Rating is basically how much something is matching. Rating is something how much is something matching with your text. Okay, let me just try capital. Yeah, capital also gives the same results. Okay, so this is how you generally go about it. The only thing I'm not able to demonstrate, why does this thing did not work while everything else is working fine. Probably there's something wrong with the way, somewhere, some type of mistake. Never mind, I'll do it in my own time. Now let's have a look at this. These are geospatial indexes, and we will talk about 2D spheres. Okay, here these are the places. We are defining a place with this location. Okay, db dot places dot find one. What happened to my typing? Okay, so I inserted this document containing a location element. If you can see this location element here, okay, it has a coordinate and the data type of what kind of data it is. Okay. Similarly, I'm inserting another document. Okay, this is only the single one. Go ahead, and we have got this. And if I say find and then pretty, then it should work. And I say don't show me underscore ID, and that's it. Okay, and also don't show me name. So we have got this 1 2 3. How come there's so many documents? 4 documents. 73.88. Okay, basically things are added twice. Never mind. They were already there. Okay. So now when we are trying to create, this is how you, when you are looking for something, and we want to say that I want the answer. Let's say what we are trying to search. Let's look at that first. We are trying to say in this circle, with this center, this is the center and this is the radius. Okay. What are the places which are lying in this? Okay. So there are two places here. Okay. There were already db dot places dot drop. Okay. There already an index and already a table. Okay. So if you see, mhm, 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 mhm. So let me just add db.places dot find places dot find. Nothing is there. Then we add this db.places and then find. Good. And then we have this. Let's just see. Okay. We have this db.places.find. We have added two documents. Happy. Now we are trying to search. We are trying to say that in this particular radius, we have drawn a circle, and we are trying to say that, hey, find me all the places near that. Okay, it has actually found it already. So without even index. Okay, okay. So does it have an index? db.places.getIndexes. Oh, it has only one index. Good. So even without indexes, it does work, but when it grows big, then it is going to give a problem. Or you can see that find and then explain. Okay, it has a basic cursor, no plans per se. Now we create a ensure index on this and then say explain. Now it shows that it has created index bounds. These are the locations it has created, if you see. Okay, and uh, and then it has created a B tree cursor. As I told you, the indexes are generally B trees, and B tree cursor on a location, and it's a 2D sphere. Okay, and yeah, now you can see that. I say pretty. Yeah. So it has found one particular point, which is Central Park, which is lying near your looking area. Okay, not airport. Okay. Hope I've not lost you. Okay. Now similarly, now we are creating another table with the places, and here the thing to you should note is the way we are defining location. This was the older way of defining location, and this 2D index is fine when we are talking about. So I created a 2D index. Let me have a look at find. So already it has some places 2D dot find. It has already, okay, there is no other. Already it was not there. Let's check what are the indexes. There are no indexes except for underscore ID. And now I'm inserting, oh, I inserted that again. I inserted Central Park again. And now I'm adding a airport into the places 2D, and then I say good. So yeah, instead of two, there are three added. Not an issue. This is how we create a index. I say ensure index on this column, and it is 2D. Okay. Okay. And now when you are searching, you say, find me, find me the people, find me the places in this rectangle. We give top left corner and right bottom corner, and this gives you a good enough number. So it shows you that there are these two, all the three which are matching. Okay. So basically it's this is how it happens. Okay. Similarly, you have haystack. Here, the important part you should note is that we can do something like geo within a box. Okay. And earlier we did a sphere. If you see, if you see geo within a centrosphere. Okay. Centrosphere as in we are specifying a circle with with the center and the radius. And this is how you do a haystack part. So you have a haystack db.hs.find, nothing is there, and now db. Oh, so basically the semicolons are now no longer accepted. So I'm trying to do hs.drop. Good. Hmm? Yeah. Okay. Yeah. Okay. Oh, I have missed so many questions. Unique index cannot be created once. No. Can you explain meta text score? Text score is generally regarding the how much your document has matched the query. Okay. So we created one more field and in that we added the text score. I think it is special documents in the second. I'll look at that sometime. I think there was some problem. Anyway, let me look at the question by Bhagwat. It works for me, doesn't work for you. Can you go a little slow with geospatial? Can you show the explain and 2D sphere index before and after creating the index? Okay, okay. So I had shown you, right? So he's saying that he wants to see what happens in case of a sphere. So basically, in case of a sphere, it is simply basic cursor, and then it scans, and later on, it creates those coordinates. Basically, it is called interval tree, and then in that it searches. So you can also give it a try. Okay, this file I'm sharing with all of you. Okay, you can I mean, you can check it, experiment a bit by yourself, and so I was showing you a haystack, okay, and in the haystack we are saying that ensure an index on a column called POS, okay. The type of the index is geo haystack, and we are adding one more column to the index called type from here, and then we are saying bucket size is blah blah blah, okay. And while doing so, and we run a specific command for the haystack search, which is an older way of doing things. Okay. So here it is showing you the command and the result. These are the result. It says that it has found a restaurant. Okay. This is the older way of doing things and is basically find or all those commands you can run from here. Okay. Okay. So this is the basic demonstration of these features. So, okay, Bhagwat is saying that I did and I have a situation. I cannot understand why the get index shows the index, but explain does not. I mean 2D sphere. No, actually it does. It does. If you see db dot. So the only reason explain my does not do that is when you are not searching, when your query does not involve the index. Okay. When your query does not involve the index, then explain will not tell you that, hey, explain will not tell you that you are using any index. Okay. Okay, cool. That answered your question. Oh, great. So this was a very short demo of various use cases, but these are very powerful tools. Very powerful tools. I did not realize its power until I actually needed one. When I had to build this location-wise search, I was talking about a Twitter kind of service, a site called Row. I'm not sure if it is up or not. We were building that. So I was helping one of my friend do that, basically a Twitter with location. And in that I had to invent my own algo, and later just to realize that, hey, this is already there. Okay, MongoDB already does that. And for that we had to build our own service, create a whole lot of things in memory, and basically it was not a very great design. So we dropped that and just started using MongoDB. That's it. Okay. And MongoDB anyway runs like a service, so it was okay. There we had to create another service on another server just for doing the location-wise search. Okay. And MongoDB does that for you for free, and you don't have to launch your own service. It is anyway as a service, so you can query it using your servers and then return the results. So, and similarly, that the power of text search you will only realize when you need one. Okay. Text search from MongoDB I've not used per se. All I've done is I've used Lucene, but important aspect of text search from Lucene is the query language which MongoDB uses is something which is similar to what Lucene used to do. Okay. So in the practical, when you are building a service with the text search or location search, you will find it very very handy to have a thing like MongoDB in place. Okay. Hope I answered. Let me have a look at your questions. Great. Should I move on now? Now that we are through. Okay. Now we are starting with another interesting and little engaging topic. So we have covered indexing so far, and here we go. Great, great, great. So whenever we talk about uh, MongoDB architecture, okay, so first thing which comes into play is replica set. Replica set, as we described earlier, it's a group of MongoD. Okay, it's a group of MongoD. MongoD is Mongo daemons. Daemons is something which service keeps on running. The objective of MongoD is to store a data and does the actual operation for you. MongoD is actually the main database. MongoD does MongoD. I think MongoD means Mongo database. So MongoD does all of the work for you, while Mongo S does the routing job for you. Okay. So replica set is a collection of MongoDs, a group of MongoDs, which provides you redundancy and increase in data availability. Okay. A replica set is basically a group of couple of computers which combine together, which all of those computers have the replica of the same data. Okay. And one of them does not have the same data. I'll describe it later. So it's a group of computer responsible for giving you a great redundancy and increased data availability. So in case one computer goes down, you exist from the another one. And when we say computer, it doesn't sound great because uh, at a single computer you can have multiple MongoDBs. So we say nodes or we say instances. Okay. And the way it works by default is in a replica set, you have a primary and then you have secondaries. There are multiple kind of secondaries. Primary is somebody who does the reads and writes for you by default. And while the other ones can also be used for reads and writes. For writing, when you write to a replica set, it is always through primary, while the reading can be done from secondaries. Okay. And primary is designated by all other network people, other nodes in this particular replica set. So people in this replica set do the voting and designate a primary. There are multiple kinds of members in a replica set. First one is primary. I just talked about the guy who is responsible, the node who is responsible for all the writing for all the writing. It accepts all the requests for writing. Nobody else in the system, in the whole replica set, does the writing for you. Okay. Yes, Gaurav. Geoindexes do take a bit of space. Okay. But generally, the space is a little more than ON. ON is n number of records. So equal to the actual data it will take. Or maybe a little more. It should not take too much of space. But maybe I need to look at the way they are doing it. It's a good question. And then I can answer you correctly as mean how many times it is going to store. The service which we wrote by ourselves was humongously memory intensive because we created sections of the whole system into small buckets or small rectangles, and they were humongous. Okay. So I don't know in this case how much it is going to take, but this is definitely a very important question which MongoDB need to answer. Okay. Now, right. It it depends on the spatial distribution as well as it will depend on the strategy they are using, whether it's 2D sphere or 2D in 2D planar or it's a uh, simple 2D index, 2D sphere or haystack. It will depend on the strategy also. Okay. Other than the data distribution. Okay. Okay. Now let us talk about replication. And then you have secondaries in the replica set. Role of a secondary is providing the reads and providing a backup. Okay. And third role is to designate a primary. Secondary will become primary after some time. Then you have arbiter, whose only role is to, if there is a tie for primary and secondary, arbiter arbiter are the tiebreakers. And then you have priority 0 and you have hidden. Okay. So let's move on. I'll one by one I'll keep on describing. Before we move on, let's talk about something called, just give me a second. Pick up a notebook. Okay. Okay. Good. So these are the first of all, before we move on, let's talk about elections. The elections role is to elect primary. Who becomes primary? Okay. Primary, I mean the guy who is responsible for all the rights. So when are the elections triggered? First, when your system boots up, or when you are initiating the replica set. Okay. Or when the moment primary becomes unavailable by whatever reasons, when peer says that this guy is not responding within 10 seconds. Peer as in it could be secondary, it could be arbitrary, or other members of replica set say that this guy has not responded in 10 seconds, which means it is unavailable to me. So it should the primary should step down immediately and elections should be contested. And then when the primary cannot contact a majority, if majority starts saying in a replica set that or primary himself is not able to contact majority, then he himself will step down. And secondary has a just a second, just a second. Yes, who is this? Yes, Sandeep here. Hey Arvind, can I talk to you after 2 hours? So in primary cannot contact a majority. Okay, so he himself will step down, and the moment secondary has a higher priority, so there is something called priority which define and which forces from our side who becomes the primary. So we ourselves, while configuring system, can also mark that this is a higher priority system. This is the data center which is has a better bandwidth. So we want that guy, and this data center is well located. We want this particular machines to become more to have the more tendency to become primary than the other ones. So we increase the priorities of that data center. So if there are other servers who have got higher priority and are eligible as in they are responding in 10 seconds, they are able to contact majority. So those criteria are taken into account. And all of this happens in the background by a way of heartbeat, or in another words sending pings. So these all machines, the all members of a replica set, keep on contacting each other all the time. So if you have n number of candidates, so there are n square pings every 10 seconds. So it does increase our network traffic, but these pings are really uh, simple and smooth. So every 10 seconds, I think it's 20 seconds to 10 or 20 seconds, they keep on sending the pings to the network, all the network computers, and keep noting down each other's responsiveness. The moment and that's the basis of the voting. Okay. So when secondaries vote, they vote based on who is actually responsive how much. And once that voting is done, newer primary is chosen out of all the candidates, all the secondary members. So before I move on, okay, great. So your question is answered, and now let me move on. So now let's get back to what is primary. And I think okay, let's get back to what is primary. Primary receives all the write operations. By default, receive all reads to until you configure the others also. In replica set, while defining a replica set, you define that hey, other you can read from secondary also. In those cases, when the read request comes in, you can read from the secondaries also in this replica set. But by default, it's primary only. Okay, every replica set can at most have one single primary. It cannot have two primaries. So primary takes all the requests from the U, ri- writes it into the system, and also creates a oplog. Writes into system as in either writes into a journal or writes directly into the collection. As well, it writes into something called oplog. Oplog is something which everybody else is going to replicate. Secondaries, oplog is a collection of operations saying at this point of time with this ID, this is what user wanted to write. Okay, the whole object, as well as uh, whether it was applied or not, that is also noted down. So oplog is a collection of such operations. Oplog is a collection of such operations, and under the hood, oplog is basically a uh, okay. I'll anyway come. So primary takes all the requests, writes it into oplog. Secondaries keep on replicating this oplog, and other secondaries can either read from primary for the oplog or read from other secondaries based on the heartbeat ping. Okay, so whosoever has the latest oplog and is most complete keeps on serving the others in the network. So this is one way the data replication happens in the replica set. And the moment primary is not available, the election is called. Now replica set, oplog. So oplog is basically a capped collection. A collection with a fixed size, the way we described earlier. Why it is fixed size? Because because all the members are going to have the same oplog, and the moment oplog's job is over, it gets cleaned up. It keeps rolling record of all operations. What does it mean? First, every operation, update, insert, or delete, is defined as operation or set of operations. And rolling record means it keeps on writing into a kept collection. And the moment a time, I mean, the moment everybody has noted down is there is enough of oplog has been copied by others, then this gets deleted. Okay, that is why it's called rolling record. And that is the reason why we keep it a kept collection. Because it's ever increasing. It's not, we are not going back and updating an oplog. We are just keeping writing to the oplog, and other people are saying I'm done, and that's why it goes, it keeps on expiring also. That's why we keep it a circular collection. So when people were asking that why do we need a kept collection, can I give a real example? So probably oplog is one such great example, and this is why it was created in the first place, the kept collection. Yes, like a history of commands, but in a very very stable fashion. The other, so it is located, if you go into indexes, you can see local.oplog.rs collection on all of the members of the members of this members of this replica set. All the members on a replica set contain this oplog into this collection. You can check it by yourself. Okay, but since it keeps changing all the time, a member imports oplog entries from other. Each operation is idempotent. This is important aspect. So what does it mean by idempotent? Meaning when an oplog operation or an operation be applied by a secondary after it has picked up some oplog entries from other members, and it is applying on themselves to replicate the data, if they have applied it already, it should not be applied any further. This is what is being taken care as part of these entries. Okay, and this is somehow managed by having a timestamp and a unique ID. And I mean, this is not something which I have studied too much, how exactly they are maintaining the idempotent property. Meaning, no matter how many times you are applying an operation, it is always be applied only once. Okay, which means that when, say, primary went down suddenly, secondary had copied some of the operation from it, and some of operations are left. Now it will ask the other neighbors, do you have the operation? It will get all the operations and then try to apply this. So, and will make sure that if there is some entry is applied multiple times, it does not damage the data. Meaning, it take care of the sequence number as well as a timestamp to ensure that idempotent property is maintained, meaning multiple times if you apply an operation, it should be applied only once. Okay, it should reach to that stage. And second is, generally the capped collection size is 5% of the disk space, but it all depends on multiple machines. In case of Windows, it's around 180 MB, while in case of Mac, it is something else. But in case of Linux, it's 5% of the disk space by default. Okay. So while defining a capped collection, if you remember, we always define a number of document and the size of the document, size of the capped collection. So accordingly, that space size is located to the capped collection. So, so oplog is the way the data replication happens in a replica set. Now people ask, like, should we increase oplog size? How much should it be? Here are a few things. If you are updating, so what are the scenarios where disk space is not increasing? Space is not being consumed on the disk while oplog is increasing at a very fast rate. This happens in case you are doing a lot of updates. Okay, in place updates. In place updates as in you are just increasing a particular field or setting or resetting a field again and again, which means the actual size of the data is not increasing while the operations are increasing at a very fast rate, at a very fast rate, such as something like stat counter, where you are counting the website visits. So to count the website visit, you keep on taking a number and keep on updating that number. So the actual size of the data is not increasing while the number of operations are increasing very rapidly because lots of people are visiting this website. And in those cases, you might prefer to increase the oplog size because your disk will be smaller, because you had computed that we don't need too much of space, you just need this number. But the operations of increment are happening at a very fast pace. Okay. So updates are in place and significant. Then updates to multiple document at once. When you are doing a multiple documents at once, so what is happening in the background is that it's creating a multiple operations and multiple oplog entries at the same time, which are going to be applied to multiple documents and going to be distributed later. In such cases like bulk import and all those things will require a bigger oplog size. Okay, so the moment you see these patterns, it is time to increase the oplog. This will happen in the exceptional cases, as I gave you an example of a stat counter, where you are counting the visits to the website, where traffic is huge from all across the world, but the actual number of visits is just a long. Okay, it's just a number. It's just a number of 64-bit which is storing this. It's not too big. I mean, it will take a long time to reach 10 to the power 2000 something. So it's just incrementing that number, and but there are so many visits, so many operations are happening in parallel. In such circumstances, you go for increasing the oplog size. So this is what is an oplog. Let me have, if you have a question. Like I see, when we do bulk insert, upload may get purged even before other replica. Not really, not really. So I mean, basically, in case of updates, right, the rate at which you are inserting the document onto the primary, at the same rate, secondaries will also read it. Okay. At the same rate, secondaries will also read it. So there are equal chances of the I mean secondary applying your changes and you taking care of this. Also, uh, this is quite efficient way. Secondaries read operations in bulk from the primary. It's not that they are reading one by one. They read in bulk from primary. So it won't be parsed. It won't be parsed. Because if you see, primary is reading from you, writing to the disk. By the time it finishes writing to the disk and then puts in the oplog, you can also, the secondaries are going to read it quickly and then keep it before it gets parsed. So in most of the cases, yes. And in this case, if you are really going beyond 5%, if you are doing a bulk insert beyond 5% of your disk size, then within a fraction of second, then you might have to go for increasing the oplog size, as you said correctly. Okay. I was trying to answer Bhagwat's question. If we do a bulk insert, the oplog may get parsed even before applying. Yeah. So now let's talk about. So I discussed about what is generally a replica set, then what are elections, then what is a primary member, then what is an oplog, and when to increase oplog size. Now the next thing which comes up is replica set members called secondary. So does anybody has questions still here? Samta, Sakti, Gaurav, Bhagwat? Okay, okay. Great, great. So which means that yeah, everybody is able to understand and or they are just being polite. Oh, okay, okay. No, Bhagwat, the thing is that replication is more like a politics. Okay. And in replication, there are these other members who are voting for it. And probably you are not appreciating it now because you are not seeing a real demonstration. So tomorrow I plan to give a demonstration on how to set up an 8 node computer. Uh, okay, 8 node computers on 8 node system on which we are going to install this. Okay, it is actually complex, Gaurav. It is actually complex. Okay. And these are the properties of replication which makes these things complex. Okay. It's more like a B2B. If you have used torrent, right? In case of torrent, people keep on replicating from each other and people keep on copying from each other. And that makes it little complex. Okay. And there are various dynamics involved. Okay. And they are talking to each other, they are voting for each other, they are designating one guy as primary and then making him step down from the. It's more like Indian elections. Okay. Okay. So, yeah. So the thing is, the moment you are running a huge service, say you are building a service which takes updates from all across the world. Per second, there are too many requests. That time, you will find it very compelling. and you will realize the impact of it a little more. Okay. Okay, so let me just go over further. Okay, so very important aspect. Earlier, what people used to do is used to do these all things manually. You think of the people who this is sysadmins who just realize that one of the server has gone down. There is a huge traffic coming from people and you are not able to serve. Ask people from Amazon who lost their Christmas sales. Okay, we lost lot of Christmas sales because on the Christmas day we used to have a mad traffic. We still have a mad traffic. Other than losing a sale, other than losing sales, we used to lose the face value in the industry. A Christmas time is a time of retailers chest thumping, where they say it's sort of a arena where retailers compete, and the next day a New York Times and all these newspaper publish that this year which all retailers website go down, and that is technological shame to these people. So if you ask these guys, system admins of Amazon, ask them. They will tell you all the war story. If you join Amazon, they tell you all the sort of war stories. And they used to do this all manually. They used to ping these machines, oh, which one is working, which is not working, and then make this primary, make this secondary, and make this failover. All of this, what MongoDB is doing by itself, was done by people who were responsible for handling this. Okay. So that is why this whole election, primary, secondary, all of this replication is done very neatly. It has come from that kind of crisis time. Okay. And as I said, that failures happen more often than you can imagine. Okay. I remember I was working with ISB, Indian School of Business, and for past 5 years, they were not able to take form submissions online. Reason was that everybody used to submit the form submission, and these were like only 2000 people. Okay, 2000 people are submitting a form. The only problem is that everybody will submit the form at the last minute, and that's where your database and everything goes haywire. Okay. And since you have not planned correctly, you have thought ki, okay, these are only 2000 people and they are going to submit over a week. That is why people came up with all of these mechanisms. Okay. I so well remember that they could not handle it even 5 times after 5 times failure. Okay. Right. So this is what it is. Let me just go around to secondary. Secondary is basically a copy of primary's data, and they can provide the reads. They apply the operations from primaries asynchronously. Asynchronously as in parallelly, without stopping any of their processes or primary's process. By default, it receives all the reads too. Uh, no, by default it does not. Okay, it does not reads too. Okay, by default you can say can receive all the reads too, as in after you configure and say replica said, hey, you can read from primary also, then secondaries will be serving the data, and that's the standard strategy. All the secondaries should be serving the data to the read operations, while primary is only responsible for write operations. Okay. And it also records the operation on oplog. The moment primary goes down, the other secondary becomes primary. he will distribute the oplog. Also, it keeps on doing the parallel checking. And replica set can have at most one primary, uh, multiple secondaries, okay, and it also records in the oplog. Okay, it's the same thing which primary does. Okay, now we have got primary, secondary, the replication happening, and the heartbeat is going on. And the moment election is called on, it can become primary. Okay. Now you have arbiter. Arbiter's role is not to keep the data, but to help the elections. So if there is a tie, then arbiter is called. And generally, the replica sets with even members will have a tie. So that's when you put a one more machine so that there becomes uneven number of votes, and then the tie is broken. Okay. And this is generally a very lightweight machine. It does not have any data at all. Any data at all. So you can even run an arbiter on a machine which is very low end, just for the sake of breaking the tie. Now we have got something called priority 0. Okay. Priority 0 is a secondary. Priority 1 means high, priority 2 is higher, and so on. So to the people who are designated as primary should have the highest priority in the domain. Out of all the members of the replica set, the people with the highest priority, the way we force it, this is our way of forcing a primary. Although primary is this is considered as a hint. Okay, so priority is generally our way of saying our order of preferred precedence in this group of members in the replica set is this. It- we convey it by the way of priorities. And the moment we say this machine is priority 0, meaning this guy cannot become a primary ever, meaning it will never be used for writes. So those are the priority 0 secondary members. Okay. So by default, these are secondary members which cannot become primary. They cannot trigger an election. They cannot trigger an election. They have a copy of data. Okay. And particular use is in multi-data center deployments. Why? Say you have a data center in US and in India, and in something like a very remote location. So you foresee that in case my data center get burned in US, I should have a backup copy. But since our network bandwidth is lower, we do not want this guy to become the primary. We want our US data center to become primary, but we want a copy of the whole data here also. In those cases, you put your this machine in a very remote location, and keep just the data, not keep just the copy of the data, but no traffic should go to this guy. No write traffic or no traffic should go to this guy. But okay, sorry. The priority 0 is can provide reads. Okay, can provide reads, but cannot provide writes. I confused this with the hidden member. I'll talk about it later. So priority 0 is for the example I gave about India was about somebody called hidden member who cannot provide even the reads. So priority 0 can provide reads but not the writes. Okay. And you can see that here there is a primary priority 1, secondary priority 0, secondary priority 1. Okay. So this the guy in the data center 2 can never become the primary ever. So all the people in the data center 1 are only going to be the primary. So Gaurav's point is that MongoDB's architecture deployment, not much actually, not much. In case of HDFS, This election never happens. Okay. Though sharding is there, and in case of HDFS, it splits the files itself, not the collection level. Okay. So there is a minor differences. If you look at both the things closely, not together, then you can answer. Okay. Oh, I think the we are 46 minutes late, right? I Okay. Oh, I was thinking the class will end at 11 o'clock. Okay. Anyway, we can take these next slides maybe tomorrow. My wife just knocked asking that. Okay. So guys, we can take it further tomorrow, and feel free to and submit all your submissions as quickly as possible. Okay. And goodbye. Hello. Yeah. Yes, yes, come. Yes, yes, yes. What? Just a second, let me confirm. Okay. Just a second. Just a second. Installation हो गया क्या फिर रेफ्रिजरेशन हो गया है अभी इंस्टॉलेशन नहीं हुआ है हाँ आज ही हुआ स्टॉप कर दे चाबी तो दे जाएगा ना Just give me